In this video, we are going to be solving equations using either addition or subtraction. So I'm going to be using some key vocabulary that I hope you understand, that we will always solve equations by using what's called the inverse operation. And inverse operation is a big fancy word for opposite. So if the equation involves addition, we will be solving it by using the inverse operation, which of course is subtraction. Okay, and the solutions are the answers for the variables that make the equation true. Okay, so here it reads, equations may be true for some values and false for others. A solution of an equation is a value that makes the equation true. So make this real simple. If I give you x plus 3 equals 7, and I tell you that the value of x happens to be 3, well, is 3 plus 3 7? No, it's not, because 3 plus 3 is 6. And so that is a false equation if I tell you that x is 3, because that's not the case. So that's why it ends up being no over here, because the both sides aren't equal. If I tell you that x equals 4, well, that is true, because 4 plus 3 does give you 7, highlighted here, which is why I've written the word yes, for yes, both sides are equal, and that solution happens to be true. And then, of course, you can see I've given you 5 as well. If I tell you that x has a value of 5, well, 5 plus 3 does not equal 7, so that's why I've written no. So the value x equals 4 is known as the solution of the equation x plus 3 equals 7. So that's just some basic vocabulary. Now we're going to jump into a few. So this is supposed to be an easy start. It says, tell whether the given value is a solution of the equation. A plus 6 equals 17. Tell whether the given value is a solution. So we have to know if it actually works. Does it solve our equations? So if I tell you that a equals 9, we're basically substituting 9 where the variable a is. So is 9 plus 6 actually equal to 17? Well, 9 plus 6 is 15. So the answer is no, a does not equal 9. That is not a solution. That's how simple that's supposed to be. Now on to maybe a bit more challenging looking problem. You have that line. So when I say that line, I'm talking a line right in between the q and the 2. It looks like a fraction because it is a fraction, but the line means to divide. So when it says tell whether the given value is a solution of the equation, this actually means q divided by 2 equals 28. So if we take the value or the solution that they're telling us, it's to be q equals 14. I take 14 and I put it in place of the q. So I replace q with 14. And what is 14 divided by 2? 14 divided by 2 happens to be 7. Is 7 equal to 28? No, it is not. So again, not a solution. Those are not solutions. Now into actually solving the equations. This is where we are going to be using inverse operations. So the moment I see subtraction right there, that means we are actually going to solve this by using addition. I'm actually going to be adding to figure out the answer. Okay, so this isn't a guessing game. You don't just start plugging in values for r to make the equation true. This is not a guessing game. Here comes the math. 15, I'm telling you, is equal to r minus 6. And the way I can picture this, if you want to see like a little visual, is that you all know what a teeter-totter is, or a seesaw, right? It's balanced. Well, on the left side, I have 15. That's an expression. And on the right side, I have r minus 6. And on the right side, I have r minus 6, also an expression. Well, I'm telling you these things are balanced, which means they're equal, okay? Well, I have to figure out what the value of r actually is. In order to do that, we're going to do the opposite, otherwise known as the inverse operation. So I'm going to add 6. Because if I add 6, my minus 6 and my plus 6 become nothing. They become 0. So all that's left on the right side of the equal sign is just our variable r. But what you do to one side of a teeter-totter, if I add 6 over here, the teeter-totter will now look like that because I've added weight on the right side. So it tips, it goes down on the right side. But whatever you do to one side, you have to do to the other. So if we add 6 on the left side, that balances our scale back out because I added 6 on the right and I added 6 on the left. Now remember, when I'm adding 6 on the right, the r remains by itself. And then all we have to do is, what's 15 plus 6? Well, 15 plus 6 is 21. So the scale will be balanced when 21 is the value of r. And we can check it to see if it's actually true. Let's actually put 21 in where r is. What is 21 minus 6? Well, that actually is 15. So we know that r, in this case, has to actually equal 21. R equals 21 is called the solution for this equation. All right, on to the next one. We've got 13 plus m equals 20. All right, just do it the quickest way possible. I see addition. Well, the inverse of addition is subtraction, so we have to get rid of 13. But what we do to one side of the equal sign, we have to do to the other. And if you have 13, but you're taking 13 away, that becomes nothing. They go away, and all that's left is the variable m. And what is 20 minus 13? That's 7. Is that correct? Is that the solution? We can check it. 13 plus, we plug in what we are claiming the variable represents. We're claiming it represents 7, so I'm going to plug in a 7. Is 13 plus 7 20? Yes, it is. So m equals 7 is our solution. So the key to all of this is to remember to always use that inverse operation. If you are going to be, if you see adding inside the equation, to solve it, you must subtract, and vice versa. If you see the subtraction sign inside an equation, you will be using addition.